All right, you should take a few minutes, try to do this starter here at the start of class. How about your homework? We're going to go over it. So sit down and try to answer this question. Farmer Brown has a field that he needs to put a fence all the way around. The field is shown on the coordinate plane. Each block is 10 feet. How much fence will he need? You can pause the video right here because I'm getting ready to show the solution to it. So pause the video and give them a chance to work on it. All right, here's how you find the solution to this. The shape that Farmer Brown's fencing in has 5 sides, so it's a pentagon. On this first side here, all we really got to do is count 1, 2, 3, 4, 5, 6, 7. So that side's 7 units long. Same thing on this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 units long. This side, same thing. 1, 2, 3, 4, 5 units long. And the bottom down here is 1, 2, 3, 4, 5, 6, 7 units long. Remember, when you're counting, count spaces, not lines. This side, we actually, which is this side right here, we actually have to use the distance formula to find its length. I'm going to write the distance formula over here. Remember, distance formula, you subtract the x's, square that answer, subtract the y's, square that answer. Distance formula. Well, we got to find the coordinates for this point and that point. So we just count to find the coordinates. We'll need those 2 coordinates. Coordinates to this point right here. Looks like we go out 1, 2, 3, 4, 5, 6, 7, and up 0. So that's 7, 0 on that point. This point, we go out 8, 9, 10, and up 1, 2. So those are the 2 ordered pairs that we're going to use in this distance formula. Our x's are 7 and 10. So I'm going to do 10 minus 7. Remember, it doesn't matter which order they go in really for the distance formula, so just to make it easier on us. And on the other one, I'm going to go 2 minus 0. 10 minus 7 is 3. Still got to square that. Plus 2 minus 0 is 2. We still got to square that. 3 squared is 9. 2 squared is 4. We add those together and you get the square root of 13. The square root of 13 is about approximately 3.6. So this side is about 3.6. Now what we're going to do is add all those sides up. We got 7 plus 10 plus 5 plus 3.6 plus 7. We got 1, 2, 3, 4, 5. We've accounted for all 5 sides. 7 plus 10 is 17 plus 5 is 22 plus another 7 out here is 29. 29 plus 3.6 is 32.6. That's the perimeter, but they said each block counts as 10 feet. Well, then all we're going to do is multiply that by 10. When you multiply this by 10, you just bump the decimal over one place. So Farmer Brown needs about 326 feet of fence. All right, on the homework from last class, so open up your books to page 34. Page 34. We're going to do some of these problems together. On this problem, I am going to just I'm going to do, just on these first ones, 17 through 24, I'm going to find the length of every side in this figure here. Then I'll worry about answering the questions. Some of these are real easy to find because they're vertical or horizontal. Others we have to use the distance formula on. So I'll go through and I'll find all those, and then we'll write them down, and then we'll answer the questions. This one here, pretty easy to find because it's just a vertical segment, so we just count 1, 2, 3, 4 spaces, so that one's 4 units long. The rest of them, it looks like we have to actually use the distance formula on, so I'm just going to start finding them. We'll find AB first, this one, using the distance formula. Using the distance formula for A and B, our x's are -5, -5's right there, -0, that's right there, squared plus 4 is our first y, -3 squared. I'm hoping you can see that green. And I'm going to do some of this math in my head. -5 minus 0 is -5. -5 squared is +25. 4 minus 3 is 1. 1 squared is 1. We add those two together and we get 26. And the square root of 26, make sure you got your calculators, is about 5.1. This side right here is 5.1. Next one, let's go ahead and we'll find segment AF right here, right next to it. Distance formula again, you're just using this over and over again. Our x's this time are -5 and -2. So -5 minus -2 squared plus 4 and 1 are our y's, so 4 minus 1 squared. Do some of the math here in your head. -5 plus 2 is -3. -3 squared is a +9. Plus 4 minus 1 is 3. 3 squared is a +9. Add those two together and you get square root of 18. And the square root of 18, again, grab your calculator. It's not a perfect square number. Square root of 18 is about 4.2. So side's about 4.2. Moving right along here, we go to, let's go to FE next. Segment FE. Come up here and do it. For our x's, we got -2. -2 and 2 for our x's. Squared plus, for our y's, we got 1 and -3. So 1 minus a -3 squared. These are going to change to plus. Be careful on this. -2 minus 2 is -4. -4 squared is +16. Plus 1 plus 3 is 4. 4 squared is 16. So on this one we get the square root of 32. Again, not a perfect square number, so you grab your calculator, take the square root of 32, and you get about 5.7. 5.7 for that side, from here to there. Next one we're going to find, we'll find ED next. That's this one right here. For ED, our x's this time are 2 and 4. So 2 minus 4 squared plus our y's, -3 and -5. So -3 minus a -5, that's a -5 squared. That's gonna change the plus in there. 2 minus 4 on this one is -2. -2 squared is 4. 3 plus, or -3 plus 5 is 2. 2 squared is 4. Add those together and you get the square root of 8. Again, not a perfect square number, so we take out our calculator, take the square root of 8, and you end up with about 2.8. So the side right here is about 2.8. And one of the problems, they tell us that this middle shape in here is a rectangle. Well, if it's a rectangle, and this side's 5.7, then this side has to be 5.7, so I'm just gonna write that in. If it's a rectangle, these two sides have to be the same. So all we really got left to do is find one of those two sides. I'm gonna find, we'll do segment FB over here. Take segment FB, we have our x coordinates are -2 and 0. So -2 minus 0 squared plus our y coordinates are 1 and 3. So 1 minus 3 squared. -2 minus 0 is -2. -2 squared is 4. Plus 1 minus 3 is -2. -2 squared is 4. That's the square root of 8. Well, we just got done doing the square root of 8, and it was right down here. It was 2.8, so that means this side's 2.8. It also means that this side over here, because they told us it's a rectangle, is 2.8. We know every segment in that picture now, so we should be able to answer every math question 17 through 24, and I'm going to do that here in 1 second. All right, problem 17. Problem 17 asks us to find the perimeter of triangle CDE. So triangle CDE. And we haven't really talked about triangles yet, but you'll probably guess that that right there is a symbol for a triangle. So we're trying to find that perimeter of triangle CDE. 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 That's this triangle right here on the end. Well, to find the perimeter, we just add up the 3 sides, and those 3 sides are 2.8 plus 2.8 plus 4. So the answer is 17. Perimeter is 5. Let's see, that's 5.6, so 9.6. And you should write in units there. I may forget to do that because I'm sort of hurrying through this. Problem 18 says find the perimeter of triangle, find the perimeter of rectangle BCEF. Rectangle BCEF. So for BCEF, B is right here, C, E, F. That's that rectangle right there in the middle, and they're telling us it's a rectangle. So on that one, we do 2.8 plus another 2.8 plus a 5.7 plus the other 5.7. 2.8 plus 2.8 is 5.6. 5.6 plus 5.7 is 11.3. 11.3 plus that, that's 16, 17. So the perimeter there is 17 units. Number 19. Number 19, they want us to find the perimeter of triangle ABF. Triangle ABF. ABF. This triangle down here on the opposite end. That one right there. Well, to do that, we're just going to add up 5.1 plus 2.8 plus 4.2. We add all those up. 5.1 plus 2.8 is 7.9. 7.9, that'd be 12.1. So 12.1 units should be the answer to number 19. Number 20. Find the perimeter of the quadrilateral ABCD. ABCD, A, B, C, D, that's the whole thing. So we're gonna have to do the whole outside and leave off these 2.8s. They're not part of the perimeter. So on this one, we're gonna add up 5.1 plus 5.7 plus the 4. And down here along the bottom, we're gonna have to find this whole length, which is 4.2, 5.7, and 2.8 all put together. So we got a 4.2 plus 5.7 plus 2.8. To find that fourth side, we're gonna have to find this side right here, we're gonna have to add all three of those. Let's see, that's 7, 12.7. Now we add all those up, we get 10.8, 14.8, 14.8 plus that is 26, 27.5. So the perimeter is 27.5 units. Don't make too much fun of me if I add wrong, because I'm trying to add wrong in my head. Just fix it. Make sure everybody else knows that I added wrong if I happen to. Find the areas on 21. So that's all those. I'm gonna erase some of this so we can do, I'm gonna erase some of this so that we can do the area of some of these figures. All right, first thing I wanna say with the areas, these two angles, this angle and that angle, are both right angles. So when we look at those triangles and we look for the base and the height, we look right there where that right angle comes together and where that right angle comes together. The first one on 21, they say is triangle CDE. So we want to find the area of triangle CDE, which is this triangle down here. Well, if you're looking at that triangle, it looks something like this. It doesn't look anything like that. It looks something like this. There's a right angle here. This is going to be your height. And where that right angle is set is going to be your base. So this time our height is 2.8 and our base happens to be 2.8. That won't always be the case. Formula for a triangle is 1/2 times the base times the height. That's the formula for area. What we're really probably going to do here is we're going to take the 2.8 times, that's the base, times the height, and then we're just going to take that answer and divide it by 2. And that's going to leave us with the area. And please don't forget that your units for this are always going to be units squared. Units squared. I grab my calculator, I do 2.8 times 2.8, it equals, divided by 2, and I get 3.92. So we'll say about 3.9 units squared. You can sort of look at the triangle, since it's on a coordinate system, and we got 1, 2, maybe 3 total blocks there, and then you got these others that almost make a full block, so it should be about 4, which it is. Problem 21. Problem 22. 22 says find the area of rectangle BCEF. BCEF, that's that rectangle. Well, the formula for area of a rectangle is just length times width. The length of this rectangle is 5.7 times the width, which is 2.8. And all we got to do is grab our calculator, and remember your units are going to be units squared. So 5.7 times 2.8. And we get about 15.96, or about, we'll say about 16.0. That wasn't written very well. 16.0 units squared. 23. Pen's going a little crazy. says find the area of triangle ABF. ABF is over here. We're looking at that. This is our height. That's our base. So for 23, all we're going to do to find the area is take that height, which is 2.8, times the base, which is 4.2. Multiply those two together and divide by 2. So 2.8 times 4.2 equals, then divide that by 2, and we end up with about 5.9. So for 23, area equals about 5.9 units squared. 5.9 units squared. 24, find the area of quadrilateral ABCD. Well, to do that, all we're really going to do, we found the area of this triangle, which was 3.9. So this one right here, area was 3.9. We found the area of this rectangle in here, which was about 16.0. And we found the area of this triangle, which was about 5.9. Instead of going back and trying to do something crazy, all we're going to do to find the total area of this whole shape is add those three together. So for problem 24, to find the area, we're just going to add together 5.9 plus 16.0 plus 3.9. We add all those together, you get 19.9, 24, 25.8. So the area of the whole thing is about 25.8 units squared. That's the area of, so if I colored in this whole thing, that's the area of all that. Number 25, they ask us to find the error in this person's work. And if you look at it, they said that the length was 4 and the width was 3. The width looks all right, it looks like it's 3, but if you look at the length, looks like they forgot to count 1. So all that would have to happen there is where they stuck in for L to fix it. So they got P equals 2 times L plus 2 times W. That's a W. And they stuck in 4 here. That should have been 5. And then if you work that on down through and you get P equals 10 plus 6, and the perimeter should be 16, not 14 like they had. Number 27. On 27, this is one like, I know that they had one like this on the end of year geometry test last year. And the easiest way to do it, you have a graph right there. Just sort of take the points that they give you and guess and check and see what the area is. If we graph the first point, they give us a point here and a point here, and then they tell us to use the point 20, which is right here. Well, this length, if you graph that, it ends up being 4. This length ends up being 1. 4 times 1 is 4, but remember the area of the triangle is 1/2 base times height. Well, this is our base, this is our height. Half of that's only going to be 2, so A won't work. If we do the same thing with B, we got this point, and then they say use the point -2, -1, -2, -1, which is right here. This length right here is still 4. This length is 2. We finish out that triangle. 2 times 4 is 8. Half of 8 is 4. That's the area they wanted. So B is the one that works. 28, they want you to use the same points that you used on 27. So we have 2 points that are here and here using that same graph that they had up there on 27. And they want you to decide, you want a rectangle with perimeter 14 units. So you want the perimeter to be 14. Well, you already know that this side is 4. Wherever the other side opposite that is in that rectangle has to also be 4. So that's 4 and 4, that's 8. That means you got 8 units out of that. That means there's 6 left. So that means these two sides would have to be 3 each. And we could sort of find those coordinates. The coordinates of the original 2 points that they gave us was -2, 1, and 2, 1. This was -2, 1, and 2, 1. Well, if we go down 3 straight units, 1, 2, 3, we're at -2. Down 3 units would be also -2. If we went down 3 units over here, 1, 2, 3, the 2, the x stayed the same, and now we're down at -2. So the 2 extra points should be -2, -2, and 2, -2. And we look, see if that's one of the choices. -2, -2, and that would be letter C. Letter C. 29. 29 says, find the area of the square EFGH and square EJKL. What happens when to the area when the perimeter of the square is doubled? Is this true about every square? So is this true about every square? So we're looking at problem 29. If we just count up for each one, we're doubling, they're saying we're doubling the perimeter. So if we count the perimeter of the first one, it looks like we have 2 squares, and on those squares, if I draw them here real quick, got a square it looks like that, and a square it looks like that. Looks like in the little square, this side's 2, this side's 2, this side's 2, this side's 2, so the perimeter of the smaller square is 8. If we double that, that means we go up 4, so this side here is 4, this side's going to be 4, that side's 4, and that whole side's 4. And that means the perimeter of the bigger square, 4 times 4, which is 16, well, the perimeter doubled. That's what they wanted. And then they said, what happens to the area? To find the area of the square, remember it's just S, area equals S squared, length of one of the sides squared. So if we find the area of the small square, that'd be 2 squared, which is 4 units. Area of the big square is 4 squared, which is 16 units. Well, if we look at these two, what happened to it is it didn't just double, it went up by times 4. And that's the answer to letter A. And then letter B is, the answer to letter B, I'm going to write it up here. Answer letter B is yes. If you double the perimeter of any square, the area is going to be 4 times as big as the original square. 32, they ask us, without doing any calculations, decide whether the square, whether the rectangle or the triangle has the bigger area. Well, if we look right on the bottom of the rectangle, if we count this bottom, 1, 2, 3, 4, count the bottom over here, 1, 2, 3, 4. So each of these is 4. I'm not doing any calculations yet, but with the rectangle, it's just gonna be base times height to find the area. With the triangle, it's gonna be base times height, but you're gonna divide that by 2. So we know that the rectangle will always have the bigger area in that case. So the rectangle is always gonna have the bigger area. Then it says, which one has the bigger perimeter? Well, same idea, sorta. If we come out here and do this, that's gonna form a rectangle on this side, just like on that side. And the distance around this rectangle should always be greater than the distance if we walk from here to here to there, and then go diagonally corner to corner there. Going out this way is gonna take longer than going here to here. So the rectangle will also have the bigger or more perimeter. All right, 38 through 43, I'm gonna go through them very, very quickly. Solve this one, solving equations that you did last year, and I'm just gonna do them very quickly, so watch carefully. 3x equals 9, divide by 3, x equals 3 in that one. That's our solution. Next one, subtract 9, you get 5x equals -5, divide by 5, x equals -1. Next one, first thing we gotta do on this one, get all the x's on one side. We subtract an x on both sides, and you end up with 4 equals -12. These x's canceled out, these x's canceled out. Anytime where all the x's cancel out, you end up with something like this, 4 equals -12. You look at that and you decide whether it's true or whether it's false. Whether it's true or whether it's false. If it's true, then you say any number will work. If it's false, then you say no number will work. Well, this one, 4 is not equal to -12, so in this case, no number will work, or we say no solution. Or, if you want to be lazy, you could use the empty set symbol for number 40. Next one. We solve this, we subtract 3x on both sides. Remember to always do your x's first. You end up with x minus 9 equals, these cancel out, and you're left with 5. Add 9 to both sides, and you're left with x equals 14. No division on that one. Next one. You always want to move your smaller x to the bigger x. Well, this is a negative x on this side, so you're going to add 2x, that negative is smaller than the positive. And we end up with 11 equals, these 2 x's cancel out, 7x minus 3, add 3 to both sides. You end up with 7x on the right, 14 on the left, divide by 7. You end up with x equals 2. This one's probably the hardest one for a lot of people. You got this big fraction here. First thing you got to do, don't make it harder than it is, you multiply both sides by 2. When you multiply this side by 2, you got to put parentheses around that and multiply everything by 2. On this side, the 2's just cancel out, and you're left with just x plus 1. This side, you got to distribute, and you're left with 8x minus 6. Subtract x on both sides. Remember, when you're subtracting x, you're actually subtracting 1x, so this is 8x minus a 1x, which is 7x, minus 6. Add 6 to both sides. I'm running out of space down there, so I'm going to try right over here on the side. You're left with 7 equals, and I ran out of space there too. 7 equals 7x divided by 7. And you're left with just x equals 1 on that last one. Sorry, I ran out a bunch of space there. So that's your homework. All right, what I want you to do next, go up, grab a protractor, and grab the handout off the little table in the front. So grab the protractor, grab the handout off the little table in the front. Might pause the video here for a minute to make sure you grab them. All right, first thing, to use a protractor, you'll notice it's got this hole right here in the middle. When you have an angle, I'm just going to draw some random angle up here. When you have an angle, you have something that looks like this. This point right here is called the vertex, where the two, and I'm hoping that you know this, the two rays come together and they make that angle. That vertex is what you're going to put right there where that hole is, or where the middle of that protractor is on the bottom. And you're going to line up one of the two sides. It doesn't make any difference which one. You're going to line up one of the two sides with this bottom of the protractor, that black line going across through there. And it doesn't matter which way it goes, whether it goes out to the right or out to the left. So I'm going to line up mine, and I'm going to make it come out this way. Notice it should hit right exactly at that right there, where it says 0 and 180. The other side can't go down here like this. It's got to go through the protractor. So the other side's going to come somewhere up through here like this. Maybe something like that. Now mine's way crooked and everything, but then what you're going to do is you're going to read that protractor and see how many degrees or what amount of turn we did if we went from here to there. If we turned that much, that's what an angle measures, is degrees, and a degree is how much something turns. Well, we get out here and we notice it's got two sets of numbers. So what you got to be able to do is look at this angle, and I'm hoping that some of you know this already, that this angle, since it's less than 90 degrees, is an acute angle. Well, we know it's less than 90 degrees, so we want to use the set of numbers that are smaller than 90 degrees. We look up through here, we get to 40. This right here would be 45. It looks like maybe we go a couple out past that. So my angle here would probably be about 47 degrees. That's the degree symbol. If we were measuring another angle, let's say we were measuring an angle that we went out this way with, and then the angle went like this, up through here. Again, mine's way crooked. So it should line up right there along that black. We got the vertex right even with the hole. And this time we go around and we notice that we get all the way around here and we got all these numbers here, and we say, okay, which one is it? Is it like 55, 65, 135, 125? Well, what you got to do is decide, hey, this is an angle that's bigger than 90, which is an obtuse angle. It's larger than 90, so our answer should be more than 90. So we use the set of numbers going around this way that gets bigger than 90. And right here we're at 120. We don't quite make it to 130. We're about halfway. So our answer there would be a 125 degree angle. That's an obtuse angle. It's about 125 degrees. Now what I want you to do, and you might have to pause the video again, is take a few minutes and measure those 6 angles on that sheet with your protractor. So again, pause the video here, give them 5 minutes or so to try to measure those, and then I'm going to go over them. All right, I've drawn the first 4 angles on there up here. I guess there was actually 7 angles on the paper, not 6. I've drawn the first 4. The first one, this one I got about 47 degrees. Now if you got 48 degrees or 46 degrees, that's probably all right. This one, it almost looks like it's a right angle, but when I measured it, it looked like it came out to actually about 93 degrees, so it's not actually a right angle. This one, I can tell it's an obtuse angle. If you put down something like 48 degrees, then use the wrong set of numbers. This angle should be 132 degrees. This one, I got about 29 degrees. The three that I don't have up here, one of them I got at about 120 degrees, another one at about 78 degrees, and then the one at the far bottom right, about 91 degrees. And again, you should be within a degree one way or the other on each of those. All right, go ahead and get out your notes, start copying this down. On this first part again, all you probably really need to copy is that title angles. This is just telling us what we're going to talk about, so I'm going to give you a couple minutes while I go over all this stuff to get out your notes and just write down the title angles. What you should be able to do after going through this lesson is be able to name angles. Naming angles sometimes is difficult, so make sure you listen carefully when I get to that part. Measure angles. I'm hoping that just doing that protractor activity there a second ago helped out with that. Be able to classify angles. When we say classify angles, that's something that you probably have already done. That's where you're saying, is this angle acute, obtuse, a right angle, a straight angle, so on and so on. Be able to use the angle addition postulate. We did segment addition postulate that looked like this. And we said that segment AB plus segment BC has to equal segment AC. This segment plus this segment has to equal that entire thing. And angle addition postulate's sort of going to be the same thing. You take two angles and you stick them together. The measure of one angle plus the measure of the other angle has to equal the measure of the whole angle. Be able to bisect an angle. We went over bisecting segments. Remember, if you're bisecting a segment, you're taking this segment and you're splitting it up into two congruent parts or two equal parts. Well, if you're bisecting an angle, you're doing the same thing. Be able to find angle measures. This is setting up equations and then plugging back in and finding the measure of the angle. This is probably the part that's the most difficult. It's not really difficult, but it's got the most work to it. All right, sides of an angle. Draw this picture, copy this stuff down, and I'm going to go over it real quick. The sides of an angle, so that's one side of this angle. This is the other side of that angle. The sides of an angle are always rays. So when we wanted to name the side of this angle, we would start here and go out this way, and we'd call it ray PK. When we name the other side, we'd start here, go out there, and call that ray PG. This point where the two rays come together is called the vertex. That's very important. Make sure you know that. Where the two rays come together is the vertex of the angle. So P is the vertex. Point P is the vertex. Interior of the angle, all the stuff inside the angle. Now remember, the angle doesn't stop here. It continues on forever and ever in both those directions. So all this stuff would be interior. Anything out here on the outside of the angle is the exterior of the angle. To name an angle. Name an angle, again, lots of different ways to name an angle, so this is sort of hard. The symbol, it's not really hard, but it's just something you got to learn. The symbol of an angle, real difficult, is just a little angle symbol. Now the difference with an angle symbol is we actually put it in front of the letters or the numbers instead of over top, the way we did with segments and rays and lines. So it goes out in front. One way we can name this angle is just angle P, just like that right there. Angle, the angle symbol, then the vertex letter. You're just using that vertex letter. That only works if there's only one angle in the picture. If you start putting other angles in the picture and they have their vertex at P, then you can't name it with just that one letter. Then you have to use this method. And I would almost rather use this method all the time because this method will always work. And that method is to use 3 letters. When you use 3 letters, you start somewhere. So let's say I start here at K, I go down to P, and then I go to G. So we name that angle, angle K, P, G. That middle letter there always has to be the vertex. Now we could name that same angle, let's say I wanted to start at K, go to P and go to G, but Johnny wants to start at G, then he can name it G, P, K, this way. But the vertex letter always has to be the middle letter. And then the lazy man's way to name an angle is if they give you a number inside the angle, on the interior of the angle, down there close to the vertex. And we can name it just using that number. And in this case, we would just name it angle 1. Other angles might be angle 2 or angle 3. So when we get a picture that has all kinds of angles in it, they'll probably do something like this and put in numbers in there. And then we can name those angles just using those numbers instead of 3 letters for everyone. Makes it a little easier. So 3 different ways to name it. 1 letter, that letter has to be the vertex. If there's only 1 angle in our picture, the way that we probably rather use all the time, because you can't mess it up unless you get them in the wrong order, is 3 letters, and the vertex where the 2 rays come together always has to be the middle letter. And then the easiest way is using the number if they happen to give you a number. So if we're looking at this picture, and if I wanted to name this angle, different ways I could name it. I could name it angle ABF. I could name it angle FBA. I could name it angle 2. I cannot name it angle B using the 1-letter method, because if I just say angle B, I don't know if I'm talking about this angle. I could be talking about one of these angles on the other side. If I wanted to name this angle, angle CBD would work, angle DBC would work, and angle 4 would work. All right, classifying angles. This is something that you should probably already know. We'll see. And I'm just going to pop these up sort of quickly and go over them. Make sure you write them down. The first one, an acute angle. An acute angle is an angle with measure between 0 and 90 degrees. It's got to be between 0 and 90 degrees. So 90 degrees isn't an acute angle. It's got to be between 0 and 90 degrees. A lot of you probably think it's just less than 90 degrees because that's what you were taught in the past. But an angle with a measure of negative 27 is less than 90 degrees, and that's not an acute angle. That's a different kind of angle. So between 0 and 90. Next one. Probably know what the next one is. Right angle. Right angle is an angle with measure exactly 90 degrees. Exactly 90 degrees. Remember a right angle? If we're looking at a right angle, that little box in the corner is a symbol for a right angle. Probably know what the next one is. Obtuse angle. An angle with measure between 90 and 180 degrees. Not 90, not 180, but between those two. And then the last one we talked about, like the first week of school, is a straight angle. Straight angle is an angle with measure of exactly 180 degrees. So it's a line. But if we wanted to measure it, we'd have to call it an angle. And then the last thing on this slide, degree. Degree is what we measured in. This symbol is a degree. and that's the amount of turn. So if you stood up and are facing forward towards the whiteboard, and then you turned and looked at the back of the room, you would turn 180 degrees. So your path would be a straight angle. All right, the protractor postulate. Just like the ruler postulate, the protractor postulate tells you how to use a protractor. We probably won't ever talk about the protractor postulate again because it just tells you how to use a protractor. How to use a protractor. Angle addition postulate. This one's a little more important. Just like the segment addition postulate. If you look over here in this picture, and if I was here, I'd ask you how many angles you see in that picture, and a lot of people say 2. There's actually 3 angles in that picture. You got this angle, angle ABC, you got angle CBD, and you have the whole thing together, which is angle ABD. Well, this angle, if it was 20 degrees, and this angle was 30 degrees, to find the measure of this whole angle, we would use the angle addition postulate and just say, okay, if this is 20, this is 30, then from here to there, that whole turn has to be a total of 50 degrees. So from there to there has to be a total of 50 degrees. That's the angle addition postulate. This little symbol right here just means measure. So this right here is red. Measure of angle ABC plus the measure of angle CBD equals the measure of angle ABD. Could also be subtraction. They could give you a picture, it looks like this. Tell you that this angle is 10 degrees and that this whole thing is 80 degrees. And they want you to find this angle right here. Well, you just take 80 minus 10 and you get that that missing part is 70 degrees. So this part right here would have to be 70 degrees. Angle addition postulate. Don't make it harder than it is. Next, congruent angles. Same thing as with congruent segments. Congruent angles, 2 angles with the same measure. Remember I told you congruent just means same measure. Well, if you're talking about congruent angles, then it's angles with the same measure. When we're marking angles, to show that they have the same measure, we put the same markings in them. So when you have angles, you just put these little arcs in them. If I put 2 arcs in that one, 2 arcs in that one, that means those 2 angles are the same. Maybe I have 2 other angles. Horrible looking angle. I have 2 other angles, and I want to show that they're the same. Put a mark in them like that, and that shows that they're the same, as long as they're marked the same way. I look down here. Those are 2 different kinds of marks. Or they're the same mark, but different than the ones that I just did, and that tells us that those 2 angles are the same. Angle bisector. We talked about a segment bisector. Angle bisector just splits an angle into 2 congruent angles. And it's always going to be a ray that divides an angle into 2 congruent angles. So if I have angle MGT here, and I run this green ray through it, and it splits it up into 2 equal parts, then that green ray, ray GP, bisects that angle. And that's what I say right here. Ray GP bisects angle MGT. And when we know that that angle is being bisected, then that's telling us that this angle has the exact same measure as that angle. So if I draw, not there, if I draw some angle here, and this ray shoots out through it like that, and it splits it up into 2 equal angles, then I know that this ray bisects that angle, splits it into 2 congruent angles, or 2 equal angles. All right, on these constructions, get a compass, a ruler, from the boxes up front, and you still have the worksheet. On the worksheet, on the other 2 pages of the worksheet, on the back of the first page and the second page, there's 2 activities. I want you to try those 2 activities. You might have to pause the video here, give them a few minutes to try them. You pause the video here, give them a few minutes, but don't give them too much time. Make sure you got time to get to the assignment. Still quite a bit more of the video to go, so don't waste all the time on these constructions. If nothing else, we'll go over these constructions at some other point. I should also say on activity 1, you're going to use the first picture on the second page of the packet. And activity 2, you're going to use the picture at the bottom of that page. So activity 1, you're going to use the first picture. Activity 2, you're going to use that second picture. All right, activity 1, it gives you a picture. It looks like this. It says draw a ray and label the endpoint D. So we're going to draw a ray. Doesn't really matter where that ray's at. And we're going to label the endpoint, which is actually the starting point. I called it the endpoint. Shouldn't probably. We're going to label it D. Then it says put point on A and draw an arc. And I should have put in there, put the point of your compass on there. Hopefully you figured that out. So you're going to put your compass point right here on A, and you're going to draw an arc that goes through that whole angle, both sides of the angle. Label the intersection points B and C. So you label these 2 points right here where that arc crosses your angle, sides B and C. Don't change your compass setting. Leave it that same thing. Put point on D, so you take your compass, put the point right here on D, and you draw that same arc. So you draw an arc about like that. Label the intersection point, point E. So we're going to label this point right here, point E. Use the compass to find the distance from B to C. So you're going to come over here, you're going to put the point of your compass on B, put the pencil of your compass on C, find that distance right there. Don't move it once you find it. Now come back over here and put your point on point E right here, and you're going to draw an arc up here on your other arc. Label that point, point F. Take your ruler and draw this ray, ray DF. Mine looks horrible. I went out too far, because what should be true about these 2 angles? If we measured those 2 angles with our protractor, we should come out to figure out that those 2 angles are congruent. They're exactly the same, even though mine doesn't look like it. Activity 2. On activity 2, it says put the point of your compass on A and draw an arc through both sides. Got my A here. So you're going to put your point right here, and again, you're going to draw an arc through there, something like that. Doesn't matter how big or long the arc is, doesn't matter where your compass is set at, just draw it through there. Doesn't have to go through C and B out there. Oh, the B and C weren't supposed to be out there. We were supposed to label these B and C. So we'll label this one C and this one B. You could get rid of B and C, sorry. You could get rid of B and C. I messed up and put the wrong thing on there. Put your point on B and draw an arc on the interior. On this, you may have had to spread your compass out a little bit because you want your point right here on B. And what you want to do is you want to come out here and you want to draw some mark like that on the interior of that angle. Now you want to make sure that you don't change that, and then you take it and put your point on C, and you draw another arc out here in the interior of the angle, and it's going to look something like that. Again, mine doesn't look very well because I'm sort of freehanding mine instead of actually using the tools. This point where they intersect, we're going to label that G, and then you're going to take your ruler and we're going to draw in ray AG right here. Now again, mine looks horrible. Hopefully yours looked a whole lot better than this. What I want you to do next is measure this angle. Take your protractor, measure that angle, measure this angle, and decide what happened. What should have happened if I measured this first angle and I came up with it being 32 degrees. What should have happened is this angle down here should have been 32 degrees. And this ray that went through here, AG, ray AG, should have bisected, or it bisects angle CAB, or BAC, whichever way you named it. So that's what should have happened. It should have bisected that angle. Hopefully yours came out looking a little better than mine. All right, page 43, this in-class assignment. I'm going to go through it, look at time. You might not have a whole lot of time to go through it. I'm going to go through it real quickly. Two angles are blank angles when they have the same measure, and that is congruent angles. And if you put the symbol down, that would be fine. Which does not belong? I have to look at the page. Different ways that we could name this angle. We could name the angle A. We could name it angle 1. We could name it angle BAC, or we could name it angle CAB. So those are 4 ways to name it. Looks like on there, the one that doesn't belong is the very first one, angle BCA. Angle BCA would start here at B, go down to C and A. That would be this angle right here, BCA. So that's the one that doesn't belong. Next, they want you to give 3 names for each of these angles. First one, angle B, we could say, just because there's only one angle in this picture, and we could name it with just the vertex letter. We could name it angle ABC, and we could name it angle CBA, going around it the other way. Number 4, we could name it angle G. Pen's not working. Angle G, we could name it angle FGH, or we could name it angle HG, angle HGF. Remember, the vertex letter has to be in the middle. Number 5, you could name that angle K. You could name it angle JKL. You could name it angle LKJ. This one, angle R, angle QR, not sure why it's going nuts, QRS, or angle SRQ. Name 3 different angles in the picture. This one, angle HMK, that's this angle. Angle NMK, and angle NMH. The 2 of them together. This one over here, angle GJC. Angle GJC. Angle CJF. And then this whole thing, which is angle GJF. Give the measures. Angle AOC. AOC is this angle. Come out there and measure it. Looks like it's about 30 degrees. We know it's an acute angle, so it has to be the smaller numbers. Angle BOD. BOD, that goes right about there. We'll use this set of numbers. Looks like about 60, about 65 degrees. Angle COD. Be careful on this one. Angle COD goes from there to there. Well, we don't start at 0 this time, but always use the smaller set of numbers over here where we start, 30, 40, 50, 60, 70, and we don't want to count like that. We just want to go 10. Here's 10, 20, 30, 40, 50, 60, 70, 80. Looks like about 85 degrees. Angle EOD. EOD. Starts here, we go about 10, 20, about 25 degrees. And I just added a couple on here, angle AOM. AOM is this one. Doesn't go, we're at a acute angle, but it goes past 60, so it's probably about 62 degrees, 61, 62 degrees. And I'm going to angle BOM, BOM, coming this way, going clear around here, we're at the obtuse angle, that looks like about 110, 115, it doesn't quite get to 120, so about 118 degrees. And then angle MOE, MOE, we do the same thing, we're about here and we go 10, 20, 10, 20, 30, 40, 50, 60, 70, doesn't quite reach 80, so about 78 degrees. About 78 degrees. 13 and 14. Problem 13 is another one of the error problems, and they're wanting you to look at that and see what the error is. They say angle BOC. BOC looks like it's an obtuse angle, so they used the wrong set of numbers. So you have to fix that. They put down 30. Looks like angle BOC should probably be about 150. Number 14, measure of angle DOE. And they give you the measure of angle DOE as 65 degrees. And it looks like DOE is only about 25 degrees. All right, we probably don't have time to work any of the problems 21 through 30. They're on your homework. Just try them. They're setting up equations. Use your brain a little bit, set up those equations. The assignment, don't worry so much about the exit question. The assignment's on page 44, 17 through 30, 33 through 39, 42, 44, 45, 46, 48, 52, 54, 56, 58, 65. It's not near as hard as it seems. Hopefully you understand most of it. Try it and I'll understand that I wasn't here to help you with it, some of it. But try it.